note along with the recording. Everybody got the notes?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So
Ma'am, I
last
have a question from last class.
Okay, I'll take the question. First, let me discuss a few points with you, and after that, I'll take the question. And if it is relevant for discussing the complex conjugate roots, in that case, you can ask the question. Is it related to the complex conjugate case?
Yes, ma'am. Ma'am, I couldn't understand the remainder term of this particular Maclaurin series. I did go and study Maclaurin series from Chiang, but for this case, I could not understand the remainder term.
Didn't you get the similar kind of remainder, when you did your first semester mathematical economics class?
Yes, I went and revised it too, but for this one, I am a bit confused as to which part of it is the an plus 1 part and which part of it is the x to the power n plus 1 part.
Okay, just a minute. Where we kept the note, I forgot. Yes, this is the thing, So you want to talk about this part?
Yes, ma'am, this last term.
Yeah, now you tell me what you didn't understand.
Ma'am, the form of a Maclaurin series, the last term is always in the form of a to an, then x to the power n, or in this case n plus 1. So, which
Yeah.
part of it is the
Here
an
we are
part?
considering the phi function. Here the function is phi, okay, and that is equivalent to sine theta, and for that matter, we are writing the expression for sine theta. So when we are writing the remainder term, the remainder term will be based on the entire function. Therefore, I have used the function, I didn't put any particular matter because here the function is in terms of the sine function. So I kept the function like this. And as you are telling, instead of n, here the series is moving up to n plus 1. And for that matter, n plus 1 factorial is coming here. And instead of x, here the element on which the function is based, that is theta. So it is theta to the power instead of n plus 1. So instead of x, here it is a sine function, and the relevant, I cannot say theta is a variable, relevant factor which is important to us, that is theta. So theta to the power n plus 1 by n plus 1 factorial is there. And it is defined on the function at p, and therefore it is phi to the power. That is the function, this function may be the linear function, the function may be any kind of thing. Here, it is the sine function. This phi is a sine function, So for the function, we have to consider the power up to n plus 1. Okay. And the last value is p. So at p, we are trying to find out the value of the function. Okay, at p, that is when theta is equal to p, say. So at that point, we are trying to find out the matter. Is it now clear?
Yes, ma'am. Thank you very much.
So similar thing, you will get for the cos function, this kind of thing. So once you understand what we are doing in case of sine function, the similar thing has been repeated in case of cos function. So last day, we presented the time path. Just I mentioned that in place of an angle, here we are bringing Vt. In terms of theta, we understood how it can be presented in terms of cos and sine function. If it is e to the power theta, it can be presented as cos theta plus I sine theta. This part we understood. However, here we have made a conversion from theta to Vt. So how we are writing this, how we can impose a time variable or replace theta by time variable, etc. That I didn't discuss in the last class. Only that part we need to understand. Whether there is, substitutability between the angle and this time variant factor. Vt is a time variant factor. So how? Instead of an angle, we are using the time variant factor Vt. This part we need to understand. To understand this, we are considering a circular function. I'm just reducing it a bit because otherwise I'll be not able to capture the circle. However, once you get the idea of the circle, for rest of the things, I'll again enlarge the matter. Is this circle visible to all of you? And I think the note is there with you.
Yes, ma'am.
So you can
Yes,
take
ma'am. The circle is
Yeah. So this circle is a unit circle. That means, the radian, the length of the radian always is equal to 1. So it can be this negative quadrant, with -1 values, or it can be in the positive quadrant with +1 values, However, it is a unit circle, which means that the size of the length of the radian is always equal to 1. So we are considering this kind of unit circle. Okay, so this is the first thing. So now I'm enlarging the matter a bit. So let's consider a unit circle. Okay, now you are understanding the size of the radius, that is equal to 1. Since angle theta is measured in radian units, the value of theta is always the ratio of the length of the arc AB to the radius R. Okay, so we are using this formula. Theta is equivalent to or approximately equal to the size of the arc AB. Though it is non-linear, we are using this non-linear component arc AB divided by radian. Arc AB divided by radian. The formula for theta is arc AB divided by radian, or radius, However, here the size of the radius is 1. So theta here is equivalent to length of the arc AB. In other words, theta is not only the radian measure of the angle, but also the length of the arc AB, which is a number rather than an angle. Okay, so we are moving one step. We started with an angle theta. Now we are finding that for a unit circle, this theta is equivalent to length of the arc, So length of the arc is a number, so theta can be replaced by a number. If the passing time is charted on the circumference of the unit circle clockwise rather than on a single line, as we do so in plotting a time series, it really makes no difference whatsoever whether we consider the lapse of time as an increase in the radian measure of the angle theta or as lengthening the arc AB. So forget about all these big things. Let's consider small things. We are familiar with this round shaped clock. Okay, maybe in your house you have a clock like this. Okay, a clock like this. So this radian can be moved clockwise in this way, and time will increase, from say, 11 a.m. to 12, 12 to 13, 13 to 14. So it will move on like this. So passing time can be placed here on this circumference. We can place the moving time, if we consider this as a clock, as radius is moving as if the time is passing. Okay, so passing time can be plotted along the circle like, 13 is equivalent to 1, 14 is equivalent to 2, 15 is equivalent to 3 in this way. Okay, and can have a full circle. So passing time can be plotted, or we can imagine that as we are moving along the circle, the time is moving from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6, 7, 8, 9, and 12. So are you familiar with a round-shaped clock?
Yes, ma'am.
Okay. And if we move clockwise, are you understanding? We are moving from 1 to 12.
Yes, ma'am.
So, will you agree with the matter that passing time can be placed on this circumference of the circle?
Ma'am, I had a question. Ma'am,
Yes.
what is the meaning of radian equals to 1 centimeter?
It is any unit, it will depend on the unit you are considering, 1 millimeter, 1 centimeter, 1 meter,
Okay.
whatever, no problem. It is a unit circle, that's all.
Okay, okay.
Unit can be anything. Okay. Now, mentioned by, nothing is mentioned here. So it is any unit. Okay. So if you agree with the matter that it is understandable if clockwise the radius of the circle moves along the circumference of the circle, we can think about passing time on a circle. Passing time on a circle. Okay, so if we agree with this matter, and if we find that theta can be presented by arc AB, any number V multiplied with T, that is, we are making V time variant. If you consider only a factor V, suppose the length is V, in that case, you are not talking about this movement, clockwise movement. However, if you multiply V by T, you are making the component Vt a time variant component, a time variant dynamic component. So in that case, the time variant dynamic component will move along the circle, and at a particular time point, first time period, if you have a specific value of V from your model, V into first period, then V into second period, V into third period. So length of the arc, if V is the common element, and if you change the time 1 unit like this, it is moving, however, the arc AB, that will remain unchanged. That will remain unchanged. Now, if you consider time is not like this, it is moving not like 1 unit, 1 unit, 1 unit. It is moving by, say, first 3 units, then by 4 units, in that case, the length of these arc, that will change. Okay. In other words, if you consider the angle, pi, it will be something. If you consider it to be 2 pi, it will be something. If you consider 3 pi, it will be something, So, if you make time variant like this, it is changing by, say, 4 units. In that case, the angle will be larger, So So it can be 3 pi. Or if you consider t to be 1 unit, in that case, v into t may be equivalent to pi. Okay, or something in between pi by 2 and pi. So it is like this. So if you change the time, v remaining fixed, your length of the arc is changing. Length of the arc is changing. That is also indicating the angle is changing from, say, pi by 2 to pi, or pi by 3 to pi by 2, 2 pi by 2, then pi by 2 to pi, then, say 2 pi, then say 2/3 pi, etc., etc. Okay, so in this way, you can change the angle as well as the length of the length of the time period, length of the time period or length of the arc. Okay, so first you are making the arc time variant. That is, you are multiplying any variable or any factor by time t. As you are doing so, your length of the arc you can adjust. It is not a constant. If you consider 1 period, in that case, length of the lag or length of the arc will be something. If you consider t is equal to first 1, then say 3, then say 5, in that case, v into t will make the size of the arc like that. Now, if you change the size or the length of the arc continuously, it will change the volume of the angle too. Now, if it is a circle, and if we say that theta is changing, in that case, it is indicating it is moving from, say, pi by 3 to pi by 2 to pi, etc. So in this way, we can make a combination between length of the arc and the value of the angle for this particular kind of circle. Tell me whether this concept is clear or not. Is it?
Ma'am, will you explain it again?
Which part? The entire thing?
Yes, ma'am.
No, ma'am, the
Ma'am,
last.
our Wi-Fi problem is.
Yes. Better to do the things. Just a minute. Let me set the board. Suppose this is a unit circle. Okay. So what I am trying to tell you, first, I think this part is understandable already in case of unit circle, because theta is equal to arc. The length of the arc
Yes,
divided by
ma'am.
the radius. Radius is equal to 1. So it is AB. Okay. So AB can be any number. Any number, say 2, 3, 4, 5, any number, the length of the arc, the size of the arc, the length of the arc, you know. Okay. Suppose now what I am doing, I am presenting AB by a factor V multiplied with T, which means I'm considering a that means suppose V is equal to half. Now, if T is the time, you know, so if you consider T to be 1, it will be half. If you consider T to be 2, it will be 1. If you consider T to be 3, it will be 3 by 2 and so on. So are you understanding this term, time variant factor? Is it clear?
Yes, ma'am. For me, it's clear.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
V is
Yes,
a
ma'am.
okay, however, time is a variable component. You consider t plus 1, t plus 2, t plus 3, etc. So accordingly, I'll be able to vary the length AB. Okay, so suppose I am considering t to be equal to 1, suppose.
Ma'am, then V is a constant.
V is a constant. You will be able to find out the value of the V from the bubble, you know, if it is, you know, if you look at the structure of your model, you will find that V will come in terms of the factors of your model. So V will give you a fixed value. It will appear in terms of the parameters of the model. So it will give you the fixed value. So suppose T is equal to 1. In that case, V into T is equal to half. Okay. So suppose, you know, half is up to this. You are getting the thing in this way. Now, say, now suppose T is equal to 2. In that case, this was the first one half. In this case, it will be equal to 1, say. Okay, so in this way, you will be able to move these radian, you know, these radian clockwise. So let me. So if this is the radian, you know, as T is changing, you will be able to move it like this. Okay. You will be able to move it like this. That means you will be able to change the size of the arc. Okay. So if you consider a particular time, it is up to this. If you consider the time to be something else, it is up to this. If you consider the time to be something, it is up to this. If you consider the time is up to this, it is like this, you know. So in that case, from your starting point, say this is your starting position. So you will be able to change the size or the length of the arc. You will be able to change the length of the arc. Sometimes it is up to this, sometimes it is up to this, starting from this position. Sometimes it is up to this, etc. And as you are doing so, starting from the vertical position, if you do so, this is the size of the angle. Then if you change the blue line to the clockwise direction, so your size of the pi is increasing, Now, as you are moving further, the size of the pi is increasing. And, it is coming up to this. Then a new circle is starting. So it can move like this. So as you are changing the time, you can change the length of the lag, and this change in length of the lag, or change of the arc, better to say, it will change the length of the arc, and the length of the arc, change in length of the arc will itself change the angle. The length of the arc, it will itself change the size of theta. So what I can write, length of AB and that will Is it understandable?
Yes, ma'am.
So I'm
Yes, ma'am.
moving the radius clockwise along the circumference of the circle, and that is changing on one hand the length of the arc, that is the length of AB, and changing AB, we are basically changing the theta too. So there is a complete relation between the movement of time and thereby changing the value of the arc, and finally that itself is changing the angle between the radius and the, it is better to say the angle, this angle, theta. So check whether you are understanding this matter, or I need to repeat any other thing. Is it now understandable to everyone? As we are moving clockwise, along the circumference, arc size is changing, that itself is changing the value of theta. Is it understandable?
Ma'am, the direction of
Yes,
movement
ma'am.
is irrelevant. No, that anti-clockwise or clockwise. The
Direction?
direction of movement of theta means
Yeah,
this is anti-clockwise. So if we go clockwise, it will remain same. I'm asking this.
It will remain same, that I am not understanding.
Ma'am, if we move clockwise or anti-clockwise, this will remain same, the value.
Yeah, anti-clockwise here we will not move, time is increasing, so I have to move in this direction only, because if you look at the clock, only clockwise movement is giving you the increasing number with respect to time. 1, 2, 3, 4, it is moving like this. Okay, because if you move anti-clockwise, in that case 12, before that 11, so it will be a different type of thing. So generally we consider it clockwise, not anti-clockwise.
Okay, yes, ma'am, got it.
So if you understand this matter, that is, unit circle can make an equivalence between the angle and VT, any time variant factor. Unit circle indicates an equivalence between the angle of the circle and a time variant component VT following the rule of a clock. In that case, we are understanding we can replace theta by VT. Okay, so moving back to our note. So if we look at the last line, so passing time can be presented on the circumference of the unit circle clockwise rather than on a single line. If it is a single line, in that case, it will be, just increasing in this way. Okay, so here we are not considering that thing. Cyclically it is moving following a circle. This is the idea. So unit circle rather than on a single line, as we do so in plotting a time series. In case of time series, we do this thing. Okay, so in a circular way we do this thing. It really makes no difference whatsoever whether we consider the lapse of time as an increase in the radian measure of the angle theta, as a lengthening of the arc AB. Thus, we may present theta is equal to VT. So as time is increasing, the angle is increasing. Okay, so angle is increasing proportionately with time. So if clockwise we consider the radius is moving in a circular way, that is indicating angle is proportionately moving with time. That there is a relation between time and the angle of the circle, angle of the unit circle. So it is proportionally related to time. As time increases, the value of theta increases. Okay, so this is the idea. So without any hesitation, if you understand the idea, without any hesitation, we can replace theta by VT. Okay, because theta is an increasing function of time. Theta is an increasing function of time. So we can replace theta by VT. So if you understand this matter, so in that case, I hope we are understanding, why from theta we moved to VT and presented the time path in this format. Any question? Any question? Next, we will go for the cyclical thing. From the circular movement, we will go towards the cyclical thing. So that will be the next part. That will be next part. So tell me whether you are understanding that there is an equivalence between the angle of a unit circle and the time variant factor VT. Theta moves proportionately with time. Is it acceptable? There is a proportional relationship between the angle of a unit circle and the time.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And the fact that in this model time is moving in a circular path rather than a linear path, it doesn't make any difference to the basic theory that time keeps on increasing. Right?
Yeah, because if it is linear, we will be not able to go for the next part. So here, not only we are replacing theta by Vt, and our purpose is not to discuss only this matter, but to discuss, from this circular movement of time, how we can generate the cyclical time path. Why? When there is a complex number, we are always getting a cyclical movement of the time path. Why we get oscillations? So that is another question. So in case of imaginary roots, why it generates a cyclical time path, that we need to answer. Therefore, we will consider the circular movement of time, not the one-way linear movement. Okay, got the answer?
Ma'am, in this case, V is the proportionality constant.
B is?
Proportionality constant.
Yes, yes,
Okay.
yes. So if you understand up to this, in the next step, we are putting different values of theta, different possible values of theta. You can put the values in between two. We are putting the standard values, theta can be 0. I am telling you, I am starting from this point, this point. So in that case, theta is equal to 0. If this is the starting point, in that case, if this OB merges with this vertical length, in that case, the angle is equal to 0. So we are starting with 0, then pi by 2, pi, 3 by 2 pi, 2 pi, etc. Are you understanding? These are the different angles in context of a circle. In case of circular function, generally we use pi.
Yes, ma'am.
So this is known to all of you. Angle is presented in terms of pi in case of a circular function.
Yes, ma'am.
No, for everybody.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
These are the
Yes, ma'am.
values. You can add more in between, no problem. Standard practices, we will consider this kind of break. Now, as we do so, we are finding that when theta is equal to 0, the corresponding sine theta is equal to 0 and corresponding cos theta is equal to 1. When theta is equal to pi by 2, the corresponding sine theta is 1, corresponding cos theta is equal to 0. When pi is equal to, when theta is equal to pi, sine theta will be 0, cos theta minus 1, and so on. So, are you familiar with these things?
Yes, ma'am.
Yes, ma'am.
Everybody, I did it at class 2 level?
Yes,
For
Yes,
this
ma'am.
of theta, etc. Okay. So if this happens, and our time series presented in terms of these cos function and the sine function, so I hope we are understanding, we are getting a flow like this. If I consider a circle, and if I consider sine theta, we will have a movement like this. If we plot sine theta against theta, these are the possible values of the theta. So if I consider, or if we measure theta along the horizontal axis and sine theta along the vertical axis, we will get this kind of movement within the band -1 to +1. For any unit circle, if we consider the sine function, we will have a cyclical pathway like this. And if we consider the cos function, for theta is equal to 0, cos theta is equal to 1. So you have to consider the point 1. After 1, it is 0, then -1. So from 1, it is 0, then -1, then 0, 1. Okay, so again 0, 1. So we are getting a cycle. We are getting a cycle. So if we consider the sine theta, then also we are getting a cyclical movement. If we consider a cos theta, then also we will get this kind of cyclical movement. So any circular function gives us cyclical pathway if we plot the sine and cosine or cos theta, sine or cos functions for the different angles of the unit circle. If we plot the sine curve and the cos curve for any unit circle, we get this kind of cyclical movement. So please check whether you are understanding this statement or not. If we start with a unit circle, then that unit circle results in cyclical movement if we plot the sine function and the cos function. Is it acceptable?
Yes, ma'am.
The logic is there in this table. The logic is there why we will get this cyclical pathway within the band ±1. So is it acceptable to everyone?
Yes, ma'am.
Yes, ma'am.
Very good. So
Yes.
gives us cyclical pathway. If we can think about circular movement of time, in that case, we will be able to generate cyclical pathway. So that we are understanding. Now moving back to our analysis, this kind of thing. Here we are not only considering the factor cos theta, sine theta, etc. Okay, so here there is an equilibrium, and against this equilibrium, we will have the movement of the price variable, say, or income variable, say, etc. So here the thing is a bit different. We will have an equilibrium value, and around this equilibrium, we will have the cycle, because, the cos theta, sine theta part that is related to, that is coming with an equilibrium thing. Not only that, depending on the value of V and T, we have to specify the value of theta. It is not necessary that Vt will follow this rule, 0, half pi, pi, 3 by 2 pi, 2 pi. It is not necessary. That theta will give us only these values, or Vt will give us only these values. So any kind of values we may have, okay? Any kind of values we may have once we consider this Vt. So this idea of Vt, any value of Vt will be merged with the concept of there is an equilibrium with it, leading towards the convergence or the divergence of the time path, etc. Okay, so we are understanding against the equilibrium value. If we start with a circle, we will have a cyclical pathway. However, it is not necessary that we will always have a unit circle, or we will be not able to ensure the value of Vt will lie in between the range -1 to +1. It will depend on many factors. Okay. Therefore, in case of divergent time path, starting from very close point with respect to equilibrium, we will have a cyclical time path. That equivalence is there. However, we are deviating. Continuously, the length is increasing, length of fluctuation that is increasing, and we are moving away and away from the equilibrium. Now, in case we get, the value, that is, this oscillation is uniform, in that case, you will have, the band within -1 to +1 as you got in case of sine theta, sine function or cos function. Okay. So in that case, around the equilibrium uniformly, that is within the band -1 to +1, it will move. Again, if we have a convergent path, that is, you will get here H is positive, here H is equal to 0, here H is less than 0. So if you have a convergent context, in that case, length of these cycle around the equilibrium will continuously fall, and over time, the path will converge with the equilibrium value. So there are three possibilities. When I plotted the unit circle, I considered these band only. It is within -1 to +1. However, Vt can take any value. Okay, so when we are getting this kind of cycle, it may not be uniform within the band -1 to +1, because there are pooling factors. This pooling factor, because along with the cos Vt, sin Vt, e to the power -mt/2n, this factor is also there. So it is changing the length of the lag, etc. And finally, we have the equilibrium. So all this cyclical movement will take place around the equilibrium. So this is the idea. First, we establish the fact that there is an equivalence between theta and Vt. After that, we show that if there is an equivalence between theta and Vt, from the notion of circle, we can generate a cyclical pathway. Then we are moving back to our analysis. In our analysis, if we have uniform oscillation, in that case, it will lie within a specific band. Otherwise, considering on the fact that whether it is convergent, divergent, you will have the time path for damped oscillatory time path or explosive oscillatory time path, etc. So this is the idea. First, from circle to cyclical path, and in our case, it is a general case. So it is not that specific case. It is not related to the unit circle. It is related to the circle. However, it is not related to the unit circle. Okay. It is not necessary that the value will come like this. And for that matter, depending on the pulling and pushing factors, convergence, divergence conditions, you will have the time paths like this. These three types of time paths are possible here. Any question? Is it understandable?
Ma'am, can you just put the equation on top?
Shagota, would you please repeat once again?
Ma'am, this is beta. Can you please show me the equation on top again, on top of the time path diagram?
This one?
The equation on top? Yes, ma'am, this one.
This one?
Yes, ma'am, I was just, yes.
Already the things are with you, and for that Today I didn't tell you to write the things, you know, because the things are with you. So there are many concepts, you know, so it will take some time to grasp. And for that matter, as I told you, you know, try to grasp the matter, take your time, do the things, you know, and try to grasp the thing. And, you know, next Monday again, I'll take the class, you know. So take your time to understand the entire thing. So material is with you, record is with you, and the book is with you. So take everything and try to grasp the matter. Whatever question you have, please write it down, you know, and keep it with you. After that, you know, by Saturday, you send the question to me. It will be best if you send the questions to Upanita and Kritika, and you put the questions in, and then send it to me. Okay. Next, I'm coming to the repeated real roots case. Repeated real roots case. Okay. So last day, I stopped with equation number 8. That is Pt is equal to A1 plus A2e to the power minus mt by 2n plus alpha plus gamma divided by beta plus delta. Since in this class, mainly our focus is on the fact that whether the time path is monotonic or oscillatory, and whether it is convergent or divergent. We are focusing on these things. As students of economics, you know, we are focusing on these factors. Whether the time path is convergent, whether the time path is divergent, whether the time path is monotonic, and whether the time path is oscillatory. I stopped with equation number 8. However, with this framework, there is a problem of linear dependence. You know, Oyon went through the entire Chiang path, and you know, he sent me this question that there is a problem of linear dependence, etc. Actually, we use the differential equations to solve the time series. You know. These technical things we use to derive the time series. You know, later, when you will learn econometrics, a bit of time series, etc., you will find that we are using the concepts of difference and differential equations to solve the time series analysis. Okay, so not only we derive the time path of these micro or macro variables, but also we generate in general the time series analysis using these formats. So in time series analysis, you know, it is important to discuss about linear dependence, linear independence, etc. Okay. Now, in this equation number 8, there is a problem of linear dependence. As we are taking command, doing the things in this way, there is a problem of linear dependence. And for that matter, it is suggested that we will write the equation as A1e to the power R1t plus A2 into t e to the power R2t plus the equilibrium value. And if we bring this t here, in that case, this equation number 8 will be extended to, you know, A1 e to the power minus mt by 2n. R1 we are replacing using the term minus m by 2n. So, you know, if I replace R1 and R2 by minus m by 2n, this equation will look like this. This equation will look like this, you know. So this we generally do when we derive the, or when we go for the time series analysis. So since you have rightly pointed out the things, it will be better to add this part in your repeated root analysis. Otherwise, you know, this problem has a linear dependency problem. Okay, linear dependency problem. At this moment, these issues are not appearing important because we are focusing on, you know, whether the time path is monotonic or whether the time path is convergent, etc. However, just keep this thing as a note so that later when we will go for time series analysis in some other semester, this idea of linear dependence, etc., will come, and you will understand why this t or multiplying the second factor by t is important. Okay, so here you keep the thing as note. I think, Oyon, there will be no problem if we keep the thing as a note.
Yes, ma'am, no problem. Thank you, ma'am.
Ma'am, can you please say what is linear dependency? What is the term
At
linear
this
dependency?
moment, I'll be not able to tell you what is linear independence, linear dependence, because, it needs a matrix algebra, okay? It uh, needs to bring the matrix algebra to understand the linear dependence, linear independence, etc. Okay, some matter is there in the Chiang, so please go through this thing on your own when you are getting the time. I'm giving you the reading time, understanding time, and trying to grasp the matter. So please go through the things. If you find the thing is understandable, then it's fine, because there is a proof, a small proof, why that this t is bringing the linear independence, etc. Otherwise, you keep it as a note. Later, when we will start talking about different econometric tools, we will talk many things regarding the linear dependence, independence. All these things will be clear to all of you.
Excuse me, ma'am. Ma'am,
Yes.
these topics are covered in Chiang from chapter 17 onwards, right?
Okay, I'm checking. 2 chapters you need to check. Chapter 16 is differential, higher order differential equations. So I think chapter 15 will be first order differential equation. Yes, 15, 16, then 17, I think, is the first order difference equation, isn't it?
Yes, ma'am.
Yes, 17 and 18, yes. 15 to 18. However, you don't need to do everything. Follow the topics covered in the class as your syllabus and do the things based on these things only. Okay. Because there may be a very long discussion about the difference and differential equations techniques, So if you go through all these things, maybe again, you will find many things are not understandable. And we also don't need to understand all the things that have been discussed in 4 chapters. So please concentrate on the matters which have been discussed in the class. That is the frame, within that frame, you may make some addition, etc. from these chapters. Okay.
Ma'am, in all the
Okay, ma'am.
other
Thank you.
modules we have done, so for example, the Samuelson model, and then the demand and supply model of the differential equation itself. In there, can a similar analysis of like cyclical path be done, considering like sine theta and everything, or is it like exclusive to this model?
When you are considering the circular time path, you have to consider continuous time. Okay? You have to consider the continuous time. Because along the circle, we cannot consider discrete time, isn't it?
Yes.
Okay, so around the clock, when you consider the time, within the hours, you have minutes and seconds, etc. Okay, so it is based, the entire idea is based on continuous time. Therefore, we add the discussion in context of continuous time, not in context of discrete time. Okay?
Yes, ma'am. Ma'am, but even if it is discrete, but even in that case, we do get oscillations, like it is again cyclical.
The sense is same. For that matter, you will find that in your book, first the continuous time differential equation things have been discussed, and after that difference equation things have been discussed, because you know the underlying concept is same. Okay, however we are making the time discrete, and for that matter explicitly we cannot bring the circle etc. Underlying concept is same. Okay, when we are doing the things in the class, first, we start with the easier thing and then we put the difficult things. Because especially in the online class, if you start with many difficult things, sometimes some problems may occur. Therefore, first we are doing the easier thing and after that the difficult things. Okay. However, if you look at the chapterization in the book, you will first find the continuous equation, continuous time, and after that, suppose the time is discrete, then this happens. Okay.
Yes, ma'am.
Okay, and you will get, several points marked in the conclusion, if n is positive, what is happening, if n is negative and along with that n is negative, what will happen, So already I discussed the matter when I talked about the convergence, etc. So no new point is here. So I hope all these points will be understandable to all of you. So if n is positive, along with that, these are positive, in that case, whether we will go for towards convergence or not, or if both the factors are negative, then what will happen, etc. So all these things are there. So please check these things. And if already you check the matters, is there anyone who could not understand the points? I think it will be better if you check the matter once again and look at all the facts and figures given here. The things will be easier to understand. Next, we are going for time path of inflation, unemployment, etc. Okay, just a minute. Just I'm coming back by a minute. Okay, so this is the inflation unemployment setup. You are already familiar with the starting point of the Phillips relation, which is based on wage rate and unemployment rate, and later how Phillips adopted the notion of inflation in this model. I think you are familiar with all these equations. Up to equation number 3, you are familiar. In fact, you are familiar with equation number 4 too, when we are considering the augmented version of the Phillips relation, bringing the expected inflation rate in the structure. So can you remember all these equations? 1, 2, 3, and 4?
Yes, ma'am.
Yes, ma'am.
Okay, so, already you did this thing, the same things have been written here. So up to equation number 4, there is no change because it is giving some macro relations. So here, whether the time is discrete, whether the time is continuous, all these things are not coming at all. So up to 4, the same things have been presented. After that, starting from the adaptive expectation model, we are bringing the calculus. In that case, we used, pi t plus 1 minus pi t, this kind of concept, Here we are bringing d pi by dt because pi is a function of time here, and we can apply calculus to consider the change in change in expected inflation rate with respect to time. So from equation 5 onward, we are bringing the calculus and presenting the same idea, similar kind of idea. In terms of idea, there will be no change at all. In terms of presentation, there will be in terms of continuous time. Okay, so if P is greater than pi, that is the inflation we are realizing at the time period T, that is greater than expected rate of inflation. In that case, pi is revised to the upward direction. So d pi by dt is greater than 0 and vice versa. The same logic was already there, j lies between 0 and 1, and the same logic is already there. However, as I mentioned, it has been presented in terms of continuous time. So equation 4 and 5 have 3 variables in a 2 equation system. 3 variables, Here you have p, u, and pi. Okay, and it is in terms of p and pi. So we are finding that 3 variables in a 2 equation system. The monetary policy equation incorporating nominal money balance M and its rate of growth small m dm by n, okay, we can state the unemployment rate as du by dt. Here also, I wrote the matter in terms of ut plus 1 minus ut in this format. Here du dt is equal to minus k into m minus p. Here m minus p is the rate of growth of real money balance. Okay. So I hope you can remember all these things, or at least some part you have in your mind that we discussed the same idea, same concept, same terms and terminologies in context of discrete equation. So here we have 3 endogenous variables: P, actual rate of inflation; pi, expected rate of inflation; and U, rate of unemployment. And 6 parameters are there. Among them, M is a bit different from the rest because M is a policy decision. What will be dm by m, how we will change the nominal money balance in an economy, that is a policy matter, policy decision. Okay. So having up to equation number 6, in the next step, we have to find out the time path of inflation rate, unemployment rate, and the expected rate of inflation. Here, I am presenting the time path for expected rate of inflation and the time path for inflation rate, as well as the time path for unemployment rate that you will complete. So to derive the time path of pi, the expected inflation rate, we are starting with this equation, equation number 5, d pi by dt is equal to j into p minus pi. And then we are replacing p, alpha minus t minus beta u plus g pi, the augmented version that we are using, minus j pi, okay. So we are presenting the things, the pi part we are keeping separate and rest we are keeping separate because we have to change this part. Okay. We have to bring everything in terms of pi. If I like to find out the time path for pi, all the substitutions, etc., will be made in such a way so that everything comes in terms of pi. Okay. To eliminate u from the above equation, we consider second order derivatives of the equation, d squared pi by dt squared. Okay. And, I hope all of you are understanding. Alpha, t, these are the constants. So when we are taking the derivative, these terms will vanish. So we have only minus j beta u. So when we are taking the derivative, we are getting the expression minus j beta du by dt. Minus j into 1 minus g into d pi by dt. Okay. So we have this equation number 7, equation number 8 in our hand. Once we get equation number 8, we will replace this du by dt with this minus k into m minus p. Okay, du by dt has been replaced by minus k into m minus p. Still there is a problem because this p is there. Inflation rate, we are moving we get rid of unemployment rate. However, the inflation rate is coming in the analysis. Okay, p is coming inside. Now again, from the equation d pi by dt is equal to j into p minus pi, the equation with which we started, we will write p in terms of d pi by dt and pi. Okay, so p is 1 upon j d pi by dt plus pi. So we will substitute this value in place of p, and finally we will get equation number 11, which is totally in terms of pi. So this is the required second order differential. This is not the differential equation in pi. Once we get the second order differential equation, as you know, we have to find out the pi, okay, or intertemporal equilibrium. We set pi is equal to pi e. And if you set pi is equal to pi e, all your first order and second order derivatives will not be there. So you will have only this part. And from here, you will be able to solve for pi e. So pi e is equal to j beta k m by j beta k, which is nothing but m. Okay. So equilibrium value of expected rate of inflation is equal to the rate of nominal money expansion. Now, when you derived this time path, time path for expected inflation rate using the difference equation framework, I hope everybody got the same result. Pi e was m.
Yes, ma'am.
So the same thing we are getting here, pi e is equal to m. Okay, so for the complementary function, the roots are, you have to look at this equation. If you like, you can write the underlying quadratic equation. However, directly from this equation, if we understand the fact that there is underlying characteristic equation is here, we can directly write down the value of the roots for the homogeneous form. Okay? Following the principle minus b plus minus root over b square minus 4ac by 2a. So following the same principle from equation 11, for the homogeneous form of the equation 11, we are getting these two root values. Okay, minus b plus minus root over b square minus 4ac by 2a. So once we get this, the time path will be given by pi t is equal to, e to the power ht into a1 cos vt plus I sin vt plus a2 cos vt minus I sin vt plus pi e, where h is equal to this and v is equal to this. From where we are getting this thing already? When we discussed the first model, we checked that we can present it in terms of sine and cos function. So we are using the rules and regulations of second order difference equation, and following all these rules, all these techniques, we are directly presenting it in terms of sine and cos. However, if you like, you can do more steps and finally you can reach at this position. So this is up to you how we will make people understanding the entire thing. So next, we will have dynamically stable time path under all three possibilities: distinct real roots, repeated real roots, and complex roots. Because the we will get stable time path, dynamically stable time path, if we can show that this h is negative. If this h is negative under all circumstances, your time path will be dynamically stable. Under all circumstances, that path will be dynamically stable. Actually, in this model, we consider beta to be positive, k positive, j positive, g lies in between 0 to 1. So if this is the context, this value is always negative. And if this value is always negative, the time path will be stable. If this value, h component, is negative, actually this e to the power ht will come to the denominator, and then as t tends to infinity, we will have the matter that this entire first part is moving towards 0, so that pi t will move towards pi e. Okay, so for that matter, if h you can ensure to be negative, in that case, you will have dynamically stable time. Okay, so for discrete roots, you will have this. For repeated roots, I am writing the equation once again because already we added a note. Linear dependence, the idea is coming from the quadratic underlying characteristic equation that we can put in a better way using the matrix algebra. Later we will do this. However, you check Chiang, if you understand the things at this stage, it will be better, even better. Okay. And finally, for the complex roots, the time path will be damped oscillatory, uniform oscillatory, or explosive oscillatory, depending on whether the H is less than, equal to, greater than 0, where H is equal to, H is given by this value. So it will depend on, in case of complex roots, I hope you understood, always we will have oscillatory time path. And whether you will have convergence, divergence, etc., or uniform oscillation, that will again depend on H.
Ma'am, but here H is always less than 0.
Would you please repeat your question?
Ma'am, I'm saying H is already less than 0 as you said above.
It is not necessary, because you can consider a framework where suppose beta is not positive, So if we consider this kind of thing, in that case it will be stable, otherwise not. Okay, so better if I put the matter in this way. I think let me put it in a general. If both roots are negative, yes. Let me put the matter in this way. Okay, so it will be easier to understand. It is always better to put the matter in a general way, and then under specific context, check what is the value. When you will do some numerical things, you will check what is the value and whether it is convergent, divergent, etc. Remember, if the roots are real, or as long as the roots are real, you will have the monotonic time path. If the roots are complex, as I hope you understood from the property of unit circle, the time path will be cyclical in nature. In that case, you cannot have monotonic time path, you will only have the cyclical time path. Okay, so you extend this analysis further in your own way, so that everything, every point becomes understandable to you. Along that, derive the time path for P and U, inflation rate, and for unemployment rate. Okay, any question? So do these and check the numerical exercises relevant for the course. It's not that you have to do each and everything. The relevant things you need to do, the time path related exercise, or the equations, looking at this, whether you are understanding whether the equilibrium will be convergent, divergent. Okay, so whatever you will do, your focus will be on these issues. Whether you are understanding the issue of convergence, divergence,